So here we're asked to draw a 3D sketch of these nets. So if I fold this back together, what I can imagine here is that this represents the bottom of a triangular prism. Okay, so I'm going to have my rectangular bottom, and then from there I've got my triangles that come up, and that gives me the triangular prism. Okay. For B, we have, this is going to make a cone. So we're going to end up with our circular base in here. So I'm going to draw a circular base. And from that circular base, it's going to form a cone with that side surface. Okay, so there's my 3D objects from those nets. Example 5 says we have a cylinder with a volume 1,000 centimeters cubed and the height is 10 centimeters. What's the radius of the base? So I know that I've got a cylinder. We have 10 centimeters of height and we want to know the radius of this circular base. So I want to know that radius there. So what I can do first is I can just work out, I can write this out in this way, the volume is equal to pi r squared times height. We have the height, okay, I'm just going to zoom in a little bit here, it's a little bit neater. That's 10 centimeters of height, and this then represents, the pi r squared represents that circular base that we want. So I'm first going to just solve for that circular base. So I know that 1,000 centimeters cubed of volume divided by the height, which is 10 centimeters, that's going to give us the area of the circular base, so pi r squared. Okay, so I end up with that circular base is going to have an area of 100 centimeters squared. Well, I can solve this algebraically for r now. I need to divide both sides by pi to get rid of the pi on the right-hand side. And then solving for r, we're going to square root. We're going to undo that square. So it's going to be 1,000 divided by pi square root. When I get that radius, I have to plug that into my calculator, 1,000 divided by pi, and that gives me a radius of 17.84 centimeters as my radius. So 17.84 centimeters is my radius. Okay, lastly, we have this hexagonal prism, and we want to know what the volume of this prism is. So it doesn't give us, it just tells us the edges are the same length. So we're going to have to use a variable here, and we're going to have to let each edge equal x. So it's going to be x, 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 like that. And the key for hexagons is that if I connect the opposite corners, each of these triangles that are made are going to be equilateral triangles. So that's what I'm going to start with. I want to find the volume, means I need to find the area of that hexagon. So the area of the hexagon is going to look like this. So I'm going to break it down into those 6 triangles. I'm just going to work with that one triangle. So if I let this height, if I want to find the area of this triangle, I need to know the height. To find out that height, I need to use Pythagoras. So I'm just going to get rid of this x here and rewrite it as half of x along this edge. And I know that the big square minus half of x squared is going to give me the height squared. Okay, so I'm going to do x squared minus x squared over 4 equals height squared. This is 3/4. Okay, so if I have one square and I take away a quarter of a square, I'm going to have 3/4 of a square left. That's going to be my height squared, and I'm going to square root this to get height. So I get square root 3, square root of x squared, square root of 4 is 2. So I get root 3x. As a decimal value, this is approximately equal to 0.866x. Okay, so this definitely is a challenge problem in that we're having to use variables, we're having to use Pythagoras, and we have to negotiate this hexagon. So I'm going to first of all find out the area of this triangle. Okay, so I'm going to find the area of this triangle here. Is going to be the base, which is x, times the height, which is root 3 over 2x, all divided by 2. So that's going to be root 3, x times x, divide 2, so it's going to be divided by 4. That's the area of a triangle. Work out the area of the hexagon. I need to times that by 6. So 6 times root 3x squared over 4. That simplifies to 3 root 3 over 2x squared. So that's the area of the hexagon. If I want to work out the volume of this, again, volume is equal to the area times the thickness. Okay, in this case, the thickness is x, so I end up with the area of the hexagon, 3 root 3 over 2 x squared, times the thickness. Well, that thickness is this line here, which is this x. So this then simplifies, the volume works out to be 3 root 3 over 2 x cubed. This represents the volume of that solid if all the edges and lengths are the same. Okay, now if you want to solve this where x is 1, you're just going to end up with 3 root 3 over 2, and you can work it out that way. But this is a challenge problem because of the variables involved, having to use Pythagoras, and having to negotiate dealing with that regular hexagon, which needs to be broken up into 6 equilateral triangles.